distinguishable. You can't tell apart this L from that L. So really, if these two L's are distinguishable, then you could just do um, the simple way of doing it. By that I mean 4. That's a y. 4 times 3 times 2 times 1. And that will give us 24. So that's a normal way of doing it. When the L's are distinguishable, this is L1, this is L2. So there are 24 different linear arrangements in this case. But for pill, without the distinguishment, that's not even a word, I think. Without the L's being the same, really there's only half the amount of numbers from the normal way of doing things. That is because that is pretty much because these two are the same. So I guess doing it is better than me explaining it. So pretty much for this for pill without the distinguishing, there is uh, let's say one arrangement of doing things. So pretty much uh, this is the formula for doing the whole thing. 2 times pill equals uh, equals the number of arrangement for the L's distinguishing pill. So pretty much, if you want to get this this example, all you have to do is you take the you take these two letters which are the same, think of them as not the same as distinguishable, and just use the formula that we have always used and just divide it by 2. So in this case, the linear arrangements for pill and distinguishable is 12 because we take 4 factorial divided by 2, and that would give us 12. So that was kind of a tricky example. So let's do another one, but this time let's use a different word. And this is actually, I took the long around way of explaining this to you, but this is actually the faster way of doing it. So let's say we have databases. So this is the easier way of going around that long around method. So the number of letters that we have the same is A's, right? We have 3 A's and 2 S's. 2 S's. So all we have to do here is we just count the number of letters that we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 letters. So we do 9 factorial divided by 3 factorial for 3 A's, and divided by 2 factorial for 2 S's, and this is your answer. And this is equal to 30,240. And I know that you're swearing at me right now for going through that long about way of doing things, but I just showed you a shorter way, so I guess I could gather some pity here. So that's the easiest way to do things. You just count the letters that are the same, and you count the total letters, and you just take the total letters and divide it by all the letters that are the same. So that's our third example. Let's just go through one last example. And this is one of the examples that I found really tricky during the time at school. And this example is when we have a circular table and some chairs, which I'll dub A, B, C, D, E, F. So here's one arrangement of doing things, right? A, if we start from here, then if we start from the top, it's A, B, C, D, E, F. If we start from B, then it's B, C, D, E, F, A. And if we continue going on like that, C, D, E, F, AB, and BF, ABC, and EF, ABCD, and F. I think it was F. Was it F? Yeah, F, A, B, C. So you're looking at this and you're asking me, what the heck am I doing? Well, I'm showing you the different linear arrangements. Because it's a circle, we don't really know where to start, right? If we had a linear arrangement like 1, 2, 3, 4, 5, 6, that's 6. If you have a linear arrangement, then we know where to start. We start from this position and we end at this position. But now we have a circle. We don't know where to start. So let's just count one arrangement and see how many different ways of doing this arrangement are there. So I just showed it to you. This is one whole way of doing things, but 6 different ways at the same time. Now that's kind of contradicting, but you can just say that uh, this whole thing is one unique lineup, but there is 6 different ways to line this up. A can be first, B can be first, C can be first. Those are the different ways that we can line it up, but then the lineup is still the same because it's the same kind of sequence, right? So in this case, what we do in this case is you just take the factorial of the number of, just take the factorial of all the letters that we have. So 6, 5, 4, 3, 2, 1, which is 6 factorial. And you divide it by the different ways that we have of getting the same sequence. So that's 6 ways, because this is the same exact sequence, just they are lined up in a different way. So 6 factorial divided by 6, that'll give us 5 factorial, because we just cancel out the 6, right? And that'll give us 120. So there are 120 arrangements around the circular table. And that's pretty much all I want to go through in this video. This is one whole section, and it's pretty simple if you look at it. All you really needed to remember is this formula. So you have to really learn this formula and have it and know it as well as you know the back of your hand. And that's pretty much it for this video. Everything's pretty simple, but that doesn't mean that you guys can go and procrastinate. What really you guys need to do is practice, practice, practice in order to get like an A in this class, because discrete mathematics is super hard. But other than that, please rate, comment, subscribe if you haven't already. Please follow us on Twitter and like us on Facebook if you haven't already, and I'll see you guys next time.